I'm the math guy, Steve. Let's try solving this equation. So when solving radical equations, our goal should be to get the radical on one side and then raise both sides to some power to get rid of that radical. Okay, so like here, we have a radical equation, and the radical is already on a side by itself, right? The square root is already on a side by itself. So we'll raise both sides of this equation to get rid of the square root. We'll square both sides of the equation. Okay, square both sides. Now, a critical part is noting that when we're squaring both sides of the equation, this right-hand side, it'll get rid of the radical, right? And so we're left with just the x plus 1. Whereas on the left-hand side, we're squaring the x minus 5, the whole side, meaning we're saying take the x minus 5 and multiply it by itself. That's what it means to square. Okay. And now, to get rid of these parentheses, we'll have to multiply this out or FOIL this out. Okay, the same thing you put on your baked potato, right? Okay, just FOIL it out, right? Okay, multiply it out or expand this expression. And so how we expand that left-hand side is by, the first times the first, got it. That'll give me an x squared, all right, okay. And then we say the outer, so x times negative 5, that's negative 5x, okay. All right, negative 5x, okay. The inner, got it, so negative 5 times x, okay. First outer, inner, so that's negative 5 times x is negative 5x. And then last, first outer, inner, last. Negative 5 times negative 5 gives us a positive 25, okay. Equals x plus 1. All right, okay, good stuff. Now we have a quadratic equation. Now to solve quadratic equations, we've got a bunch of ways to do that, right? We could quadratic formula or complete the square, but factoring is usually the quickest or easiest way if we can, right? So here, we would, to try factoring, we would start solving by factoring. We get 0 on one side and factor the other side. So here, let's try to get 0 on one side. First, combine like terms, okay, x squared minus 10x plus 25. Equals x plus 1. And now getting 0 on one side, we would subtract x from both sides and subtract 1 from both sides. So that gives us x squared minus 11x plus 24 equals 0. So we got 0 on one side. Then we try factoring the other side. Now, this is 3 terms with a 1 in front of the x squared. So we can go straight to what I call double bubble. Okay, double bubble. X and x. And we need numbers that multiply to give me 24. Combined to give me negative 11. Okay, so that would be 8 and 3, but I need negative 11, so negative 8, negative 3. Okay, easy stuff. So get 0 on one side, factor the other side, set each factor equal to 0. Okay, so x minus 8 equals 0, and x minus 3 equals 0. And we solve each of those separately. Okay, so here we add 8, we get x equals 8. Got it. And here we add 3, so x equals 3. Got it. Easy enough. So there's us solving an equation. Wait! Anytime you're solving an equation, don't forget that Nike step, okay? That check step, okay? So we definitely want to check this, and how we check it is by plugging it back into the original to see if we get a true statement, okay? So let's try checking it. Let's try it. All right, so here, let's check it. Plug it back in, see if we get a true statement. Okay, so if I plug in 8 here, let's see if I get a true statement. Okay, that would give me 8 minus 5. Plug in for every x, right? 8 minus 5, is that equal to the square root of 8 plus 1? Let's see. 8 minus 5 is 3. Is that equal to the square root of 8 plus 1 is 9? Okay, so is 3 equal to 3? It surely is. All my life, that's been true. Okay, so we know 8 is a solution to this equation. Got it. But let's check 3. Let's see. 3 minus 5, is that equal to the square root of 3 plus 1? Is this true? Let's see. 3 minus 5 is negative 2. Is that equal to the square root of 3 plus 1 is 4? Well, the square root of 4 is 2. So is negative 2 equal to 2? Is that true? No, it's not. So this actually is not a solution to the equation. So we did all the algebra correctly, except this time we got what's called an extraneous solution. Okay, so that's why we always want to check it, especially when you have radical equations, okay? All right, so again, solving radical equations, not too bad. Get the radical on one side, and then raise both sides to some power to get rid of that radical, then solve from there. Here we have to solve the quadratic, right? But making sure we check at the end, the Nike step, okay? The check step at the end to make sure we get a true statement, okay? So always remember, math is everywhere.